Part 2, we're going to take a look at a few more examples. So let's go and take a look at number 3. It's y equals 3x over x minus 2. And if we try to do this one, very easy to do. One, we're going to look at the domain. Now this one's going to have a different thing too, because if you notice we have an x on top. Now the domain's the same, x minus 2, so x can't equal 2 here. And I want to see if it has any holes. So still no holes because x minus 2 won't cancel with anything on top. So we still can't cancel. None. The next example will have that. So since the domain is not a hole, it must be a vertical asymptote. X equals 2. It's multiplicity of 1. The power is 1 on it. Next, we look at the horizontal asymptote. Now, for the horizontal asymptote, if you compare the degree on top to the degree on bottom, just like you did that last year back in Algebra 2, the degree on top is 1. The degree on bottom is 1. They're equal. So the rule says if they're equal, we use the ratio. And we're going to talk more about why this happens in calculus. But the idea is, as x goes to infinity, horizontal asymptotes deal with the end behavior. What happens at the very end? We don't worry about that 2 there. We get 3x over x. And we'll deal more with that issue in calculus. So it's the ratio. It's 3 over 1. It's the ratio of the power, of the largest powers. Coefficient. So it's y equals 3 over 1, which is just y equals 3. So there is our horizontal asymptote. Now, we next need to see if it crosses. Now, we don't always have to check this one, but we always should. Plug the 3 into your equation. We get 3x over x minus 2. And if you notice this time, let's distribute. We get 3x minus 6 equals 3x. And the 3x's cancel. So again, whoops, since negative 6 doesn't equal 0, it does not cross. Okay. Next, we need to find the slant asymptote. Again, none, since we have a horizontal. Okay, and off to the side here. Now I go up to the side. I look for the y-intercept. Get a point. X equals 0. We get y equals 3 times 0 over 0 minus 2. Just 0, 0. So this will cross the y-axis at the point 0, 0. Look for an x-intercept. Let y equals 0. And I get 0 equals, be very careful, 3x over x minus 2. Cross multiply. I get 0 equals 3x, x equals 0. So this will also have an x-intercept at 0, 0. And now we're ready to try graphing this function right here. List any asymptotes. We have x equals 2, m1, y equals 3, and list any points that we have. We got the points 0, 0. So if I try sketching this graph, at x equals 2, I have an asymptote. Y equals 3, I have another asymptote. And my only point is at 0, 0. So how is this going to look? Well, functions are attracted to asymptotes. They want to get there as quickly as possible. Now, we can't go up this time because we're blocked by this asymptote. And we know we don't cross it. So, how does it look? It can only go down. And on the other side, don't make it go down. It has to go towards the asymptote again, like so. And on the other side, because it's M1, if it goes down this side, because it's M1, goes down 1, up the other. It has to look like this. And there's our graph. All right. Now, number 4, we do have to change, because otherwise we won't be able to do number 4 just yet. So we're going to change number 4 just a little bit here. So, for number 4, we're not ready for the way it's written right now, so we're going to rewrite this as y equals x squared plus 2x minus 3 over x squared minus 2x plus 1. Now, with these problems, you want to factor them, okay? We need to factor this. If I factor the top, very easy to do. We get x plus 3 x minus 1. And if I factor the bottom, I'm going to get x minus 1 squared. And you can verify that if you need to. Now, what I want you to pay attention to is we have something that will cancel, which means we're going to have a hole. Dear Liza, a hole. But first, let's get our domain. X still can't be 1. It cannot be 1. Okay? Now, after I get my domain from negative infinity to 1 or from 1 to infinity, after we get our domain, then we worry about the holes. So to get the hole, I'm going to look at my equation again. X minus 1 over x minus 1 squared. My hole, it occurs when I cancel out an x minus 1. So we're going to have a hole at x equals 1 because this is the one that cancels. Because the x minus 1 cancels, that tells me we have a hole at x equals 1. So what we need to do now is come up with a new equation. So once you canceled out, write out your new equation. X plus 3 over x minus 1. From now on, this is our new equation. This is the only equation we use. So, to find the hole, here's what you do. If x equals 1, we have to find the point. So, to get the hole, x equals 1. To get y, we're going to plug it in. 1 plus 3 over 1 minus 1. And I get 4 over 0, which is kind of interesting for us. So I'm going to go back and fix this one. So, for example, number 3 here, or 4 here, sorry, we're going to rewrite it as y equals x squared plus 2x minus 3 over x squared minus 3x plus 2. Now the first thing we have to do is we have to factor it. Okay, we like these factored. So I'm going to factor the top. I get x plus 3, x minus 1. The bottom, we get x minus 2, x minus 1. Now hopefully the first thing you notice is those are going to cancel. Okay, but we're not going to cancel it just yet. When we get to the whole part, we'll cancel that. So I get my domain, same as always. What can't the bottom be? Well, the bottom cannot equal 2, and the bottom cannot equal 1. So that's my domain. So how do I write my domain? My domain goes from negative infinity to 1, or from 1 to 2, or from 2 to infinity. Next I get, are there any holes? And yes, because something's now canceling. The x minus 1's cancel. Therefore, we have a hole at x equals 1. Now, how do we find the hole? The hole is a point. Now, it's a pointless point because it's a hole, but we still have to find it. So we write our new equation. Y equals, now I'm going to cancel those out. I get x plus 3 over x minus 2. So to get my hole, x equals 1, plug in my y. So to get my hole, x equals 1, y equals 1 plus 3, 1 minus 2, I get 4 over negative 1, so it's at negative 4. So my hole is at the point 1, negative 4. We will have a hole there. Sorry about that. Now after you get your holes, then you have to deal with your vertical asymptote. Now, remember, you can be a hole, you can be an asymptote, but you can't be both. So, x equals 1, hole, it canceled. So the x equals 2, my vertical asymptote, x equals 2. And it is, again, m1. To get the horizontal asymptote, don't use the original one, use your new equation. From now on, that's what we're going to use. Okay? Get the degree on top and the degree on bottom. The degree on top is 1, degree on bottom is 1. It's equal, so it's the ratio. Ready? 1 over 1, so it's just y equals 1. Again, there is no slant asymptote, and that is because we have a horizontal asymptote. And next, we got to get the x-intercept and the y-intercepts. The y-intercept, let x equal 0. Go to use your new equation. Don't use your old one. Y equals 0 plus 3 over 0 minus 2. I get negative 3 halves. So we get 0, negative 3 halves. Get the x-intercept. Same thing, the x-intercept. Okay? To get the x-intercept, let x equal, or y equals 0. 0 equals x plus 3 over x minus 2. Solve it. I cross multiply. X minus 2 equals x plus 3, or it actually just equals, excuse me, that's terrible mathematics. Cross multiply. 0 equals x plus 3. X equals negative 3. So we get negative 3, 0. Alright, that took a while. Go back through and check these if you need to, because now we're ready to graph it. So to graph these, I need any asymptotes. And we have them at x equals 2 and y equals 1. Any points that we came along the way? Now it's a whole, but it still counts as a point. 1, negative 4. I'll just identify it as a whole. We have the y-intercept, 0, negative 3 halves, and the x-intercept, negative 3, 0. And this is how I graph it. Okay, the x1 is at 2, and y equals 1. I look for any points that I might have. Negative 1 up 4, there's my whole. I draw it as a whole. 0, 3, negative 3 halves. Is that... Oh, so that's embarrassing. It's at 1, negative 4. Sorry, it's at negative 4. 1, negative 4. I drew my whole wrong. Sorry about that. Please be careful. Make sure you fix that, okay? And at negative 3, 0. So here's negative 3, 0. And how is this going to look? Kind of like connect the dots. There's a hole. Keeps going. Go towards the asymptote. Now, remember, it was M1 again, so if it goes down here, it has to go up on the other side, and there's our graph. All right, we have one more example, okay? So unfortunately, you will have to go to a part 3 on this one. I do apologize for that one, but you do want to take a look at that last example. So look at these over again if you need to.